This video goes over use of the single series effect size calculator, specifically focused on calculating non-overlap of all pairs, standardized mean difference, and log response ratio effect size estimates. Here I'm using data from a 2013 study by Laura Bassett and Teresa Tabor Dowdy that implemented a dog reading visitation program where students read self-selected books aloud to therapy dogs. This study evaluated the effects of the program on the academic engagement of students with emotional and behavioral disabilities. The primary dependent variable was percentage of time on task while reading aloud. For demonstration purposes, I'll focus on calculating an effect size for student 2. First, I begin by entering values for the outcome data from the baseline phase in the Phase A field. I can manually type in all the values using commas, spaces, tabs, or hard returns to separate the numbers. I can also copy and paste them directly from a spreadsheet. Then I need to enter values for the outcome data from the intervention phase in the Phase B field. Before calculating an effect size estimate of this intervention, I might want to look at this data from the study plotted on a graph. It's a good idea to do this to check that I've entered the data correctly. To see a graph, I can check the Show Graph box to display the data I've entered. Now that my data points are entered, I can look at either non-overlap or parametric effect sizes. First, let's consider calculating non-overlap of all pairs, or NAP. I make sure we are in the correct tab for calculating non-overlap measures and use the effect size index dropdown to select the effect size I'm interested in calculating, in this case, NAP. Direction of improvement specifies whether I am expecting improvements corresponding to increases or decreases in the outcome measure. In this case, I'm aiming to increase on-task behavior, so I'll select increase. Confidence level specifies my preferred coverage level for the confidence intervals for effect sizes that have known sampling variances. The default is 95%, which I will keep as is for right now, but you can adjust to your needs. The digits option gives the number of digits reported for the effect size estimates in confidence intervals. The default is 2, which I'll adjust to 3. Results are now visible on the right-hand side of my screen. Here, I have an effect size estimate of 0.97, which tells me that there is an estimated 97% probability that a randomly selected observation from the treatment phase improves upon a randomly selected observation from the baseline phase. I also have a standard error estimate of 0.036, which gives me a 95% confidence interval of 0.673 to 0.998. Checking the Show Methods and References box will provide information on the definition and estimation of the effect size index that I've selected, as well as references for this information. Now, say I want to calculate a standardized mean difference, which is a parametric measure. I make sure we're in the Parametric tab on the left-hand side and select SMD in the dropdown. I've already discussed that my direction of improvement is increase, and I once again have options for confidence level and digits. I'll keep them as is for now, but you can change them for your personal needs. There's only one choice which I have not discussed, what to standardize by. This determines whether the effect size will be calculated using the standard deviation of the baseline observations or by the standard deviation pooled across the baseline and treatment phases. I will select baseline here, but you should select what is most useful for you. Again, results are visible on the right-hand side, and the Show Methods and References box is available to look at. The estimate of 1.103 indicates that the average percentage of on-task behavior shifted by 1.103 standard deviations between the treatment phase and baseline phase. This estimated effect size has a standard error of 0.483 with a confidence interval of 0.155 to 2.05. Note that the app also reports the baseline standard deviation. Since the outcome measure is percentage of on-task behavior, the baseline SD indicates that the standard deviation of the data during the baseline phase was a little more than 13 percentage points, which is consistent with what I could see in the graph. Finally, I'm interested in calculating the log response ratio, specifically for increasing outcomes. Increase is selected as my direction of improvement, and I can leave my confidence interval and digits as they are. Here, I will also select the Convert to Percentage Change box to give me an additional output that can aid in the interpretation of our result. I can now consider Outcome Scale, which tells the calculator the units in which the outcome measurements are scaled. This could be a percentage, proportion, rate, count, or other. In our case, I'm looking at a percentage, so I will select that. Total intervals per session, if relevant, is used for calculating a truncation constant for mean levels very near the floor of 0. Here, I'll leave it blank. Session length is used for that as well, and I'll leave this blank. The user-specified floor constant also provides the option to specify your own truncation constant instead of the constant calculated based on information in previous fields. I will leave this blank for now. Just as before, my results are visible on the right side of the screen, and I'm able to examine the definition, estimation details, and references. My effect size estimate of 0.23 represents the natural log of average percentage of on-task behavior in the treatment phase divided by that of the baseline phase, giving me a relationship in terms of proportionate change. I also have a standard error of 0.087, giving a 95% confidence interval of 0.059 to 0.401. The app also shows this effect size converted to a percentage change. It is estimated that there is approximately a 26% increase in on-task behavior from phase A to phase B, with a 95% confidence interval of 6.1% to 49.4%. In this video, I've demonstrated how to use the single series effect size calculator to compute non-overlap of all pairs, standardized mean difference, and log response ratio effect size estimates. Of course, there are other effect sizes that you can calculate using this app, and it's up to you to decide which effect size estimates are most useful for your work. Also, if you have several cases in one dataset, you may want to explore our multiple series calculator, which I'll demonstrate in a different demo.